Okay, so I'm just going to run through quickly a description of some of the plugins and components that were created within the project to do those effects. So first of all, set capture. So this is work that was done at the Foundry, and our interest is being able to go out on set and use almost casual digital stills to build up your 3D assets. So this isn't the statue you saw in the shot, but you might typically, to achieve that statue turning to gold, you do a range scan of the statue, you then match move it to the principal camera so that you can use the 3D model to do the gold transform. But instead of using a range scanner, can we go on set? Can we just take 10 or so images really quickly with digital camera and build up that 3D model to use in post? So this plugin right here, for Nuke, takes a set of images, it pulls them together, it automatically calibrates them to create the camera models, the point of view from which those images were taken. So that's the result of the plugin down at the bottom there. So you might use that information to go and model by hand. You might want to take that out to Maya and build up the model yourself. But we also want to be able to automatically create these 3D models for use. So there's another plugin that matches across images to build up dense point clouds. So the thing that you can't really see very well on the right is actually a point cloud. So it's a very dense point cloud defined in 3D geometry. So there's a plugin that matches images and it creates point clouds from it. There's also another plugin that takes those point clouds and creates a mesh. So that's the statue shot you saw turning to gold had a mesh created from these plugins transforming to gold, and it was match moved to the sequence to create the transformation effect. So the kind of cool thing there is that there was no need for a range scanner, and there was no need for the manual process of modeling the statue. So the question for the end users is, did that really improve the workflow for their post-production? Was it quicker to go down that route? The interesting thing from the production side, was it quicker to go out and take a few pictures, or would you have range scan anyway? So that's the sort of thing, in the project we're moving on to that evaluation stage next, answering those questions. Okay, that's a bit of set capture. So the University of Surrey have also been working on set capture from a slightly different perspective. So here on the right-hand side, you can see two environment maps taken using a spherical line scanning camera, the Spheron camera on the left here. And you take those two environment maps at different heights. From the different positions, you get parallax, which tells you about the depth in the scene. So if you take those images taken at two different heights, you can treat that as a stereo pair of views. You can calculate disparity, and from disparity, you can calculate the depth. So there's a set of plugins to calculate depth maps from HDR images, and from there, is there a way of turning down the lights at the front here? There's a 3D model in Nuke. You'll have to take my word for it. So down the back here, this is the quarry. You can see the back edge of the quarry. And a little circle here sits underneath where that spherical image was taken. So it doesn't scan underneath the camera. So this is moving towards a replacement for LiDAR. So if you wanted to capture your set, you'd actually have to lock down your set for half a day or a day, move your LiDAR scan in, and scan at different points. And then, of course, you've lost the production time. It costs a lot of money to lock down the set. So here, if we can do a capture like this in a matter of minutes, you can go in on the break. You can go in at lunchtime, capture the set, so you don't disrupt the production. So they also have, thanks very much. They also have a set of plugins they've created that match up different scans. So at the top of the image, you have the HDR images that are taken at two different locations. You can match those up so that you can register the 3D model. So what you can't see very well at the bottom is a full model of the quarry where this production was shot. I don't know how many scans are here, I'm guessing 3 or 4. And they've all been registered together into a single model. So the cool thing here from the production side is maybe we don't need LiDAR scanners anymore to get these types of sets. Okay, then for the performance capture side, set capture, we've had, you can see it now on this image here. So we've got a red camera here doing our photography. And the University of Surrey in the project have been developing a portable camera system. So they went on set with 16 prosumer Canon 8D cameras shooting 1080p. So they're all gen-locked together, so they're all synchronized with the red camera. So using all those views, we want to capture a structured 3D model to create that gold transformation effect in post. before you can go away and calculate your 3D models, you've actually got to map out the subject that you need to reconstruct in 3 dimensions. So Trinity College Dublin have been doing a suite of matting programs. So for the principal camera, you're going to want a really accurate map for the principal character here, the geometry is correct in the silhouette outline. So they've got a set of tools to help you hand draw the edges for your roto, automatically create tri-maps to find exact foreground and background regions, and pull the alpha map in a narrow, undefined region in between. They also have a set of tools that allow you to quickly add paint strokes to pull foreground or background in unknown regions. So it's all about increasing the workflow in pulling those maps, easing up the process of rotoscoping. They also have some plugins that help make these maps temporarily consistent over time to stop the boiling at edges. So that's the principal camera. So it's a hand job, as it were, a manual task. But if you've got 16 cameras, that's going to take forever to do. Say you've got 500 frames in a sequence, you've gone from matting 500 frames in a single camera to 500 frames in 17 cameras. Do you really want your artist doing that? It's going to take a lot of post-production. So we've also been working on automatic segmentation and matting. So Cert ITI have been working on semantic description of footage. So here, they've semantically described the footage with a person. They found the person in a bounding box. Once you have a box, you can go and pull the mat inside if you have a background plate. So the witness cameras didn't move. We had a background plate for them. We then found the person automatically by labeling the footage with a semantic description of a person. We then pulled the mat automatically for those views. Okay, so we've found the queen in each of the cameras. If you have the queen available in every single camera, you can start to reconstruct the 3D model. So there's the 3D model of the queen, there's the principal camera, the red camera, and all the witness cameras. So the University of Surrey have been working on taking the reconstruction and turning it into a temporary coherent structure. So essentially they've been reconstruct the mesh at frame 1, track it over time, so that you can overlay the effect of frame 1. As you propagate the effect on the mesh, it will be consistent and match over time correctly. So that's the performance capture end, but this is actually done on set, without any additional markers attached to the person. So the Foundry, we've also been looking at the same thing for facial performance capture. So you typically want to do that in a studio setting, draw lots of markers on the face so you can track it exactly. So we wanted to do that almost ad hoc. Add some extra cameras in, calibrate them through the footage only without any calibration objects, create a mesh at frame 1, then track it over time to create the gold effect. Moving on, I'm running out of time. And last but not least, is the semantic labeling work from Cert ITI. So I mentioned about labeling people for matting, but you also might want to label a particular class of objects. So we happen to have a lot of cameras in the way, not footage. So you might want to tag up all the frames that have cameras that you need to go and paint out. So that's semantic labeling. Also semantic description. So this is describing the activity, the start and end points, and the different activities that are happening for multiple actors at the same time in the footage. So this is more aimed at an archive and retrieval situation. So you come to another production, maybe you want to retrieve some assets for reference. You go and label your database, and then you can retrieve it. So I'll skip through there quite quickly. Just to sum up, 3-year project, it's finishing at the end of this year. We had research was focused on set modeling, performance capture, and semantic labeling of multi-view footage. And they've been developed as prototype tools for Nuke. And we're currently in the stage of completing the post-production task. And you've seen the state it is now, and thanks very much to Booth for the fantastic job on that. And we're now moving into the evaluation phase and getting feedback on all that work. So there's quite a few members of the i3D Post team here today. If you're interested in talking to them, they can chat afterwards, and it's always good to hear what people think. Thank you very much. Thank you.
We're quite short of time, so
no
very restricted question. Are there any questions, any particularly burning questions? No? Right, once again,